Okay guys, this is another scene from Factory IO. On this one specifically, this is two conveyors. As you can see, I'm stopping on the first conveyor, then moving on to my second conveyor, and there, as soon as this sensor is made, I'll wait just a few seconds, and then the scene is automatically reset and started all over again. Now the code, it's a little bit efficient because you turn off this conveyor if we're not using it. So in order to save energy, so we're doing this, and the whole sequence on component workbench was completed in just one single run. So I'm going to show you the code. This is my program over here, and the variables that I created. As you know, the variable has to be for factory IO. They all has to be global variables. So this is my global variables over here. Just the two sensors, the two conveyors, and my bits that reset my scene, and the one that tells me that it is running. Okay. So right here on my code, as you can see over here, I'm using stepping logic, like always. I created on my local variables, I created my stepping logic right over here, a double integer, which gave me up to 32 steps. And then on my code, I got my bits that the, hold on one second, let me put this on stop mode. See? This bit, it's the one telling me to go ahead and start running. If I put it on stop, it will not run, but if I go ahead and click on it, the entire sequence will start running again. So if my step one is not made, and my Boolean sensor, which is this one over here, it's on, which it should be on because it's normally closed, then I'm allowed to start my sequencer. So my sequencer starts with an entry, latching, and then move on to the next one. When that the load blocks this sensor, which is over here, and then I will stop that first conveyor. I will unlatch that bit, and then wait just a few seconds, and then move on to the next one and turn on the next conveyor on this run over here. Until further down the road, I can see that the sensor has been cleared, which is this behavior over here. The load is blocking, just 1 second, 2 seconds, and then boom, I wait until this over here turns off. You see that sensor over there? It turned off? Good. And then the same thing over here. This sensor detects the load, and then there you go. This run takes over, which is step 4, and then that way I can just unlatch my exit conveyor. Then something funny happens over here that made me create an additional run, and the problem was that when you if you use a OTE for resetting factory IO, the communication lag. Hold on, let me stop this noise over here. I had to use a latch and then wait a second and then unlatch my factory IO bit, because if you use, I did use an OTE over here, but the OTE was so quick and so fast that it didn't make it all the way through the factory IO. A factory IO sometimes can see it, sometimes it would react and then reset my scene over here. Reset, this is the button right here, resetting over here. So, but sometimes it did not. So using that OTE here doesn't make any sense. Go ahead and use a latch. Wait 1 second over here for that latch, and then unlatch it. After that, on my next branch, I will just boom, bingo. I will just move a 0 to my stepping logic and reset my entire program. All right, and now below, I added this below. It's just 30 seconds. What this run does is If I'm inside my program logic, if I'm running my program logic, therefore my step one has to be latch all the time while this program is running. I'm gonna go ahead and wait 30 seconds. This is just like a timeout. If within 30 seconds I don't finish this entire logic, then I would reset absolutely everything. I will turn off both of my conveyors, and I will move a zero to my stepping logic, thus disabling this entire program. All right, let's test that. I haven't tested. Let's see if it works. I'm gonna go ahead and start the logic again, but this time I am going to create a fault on this sensor. So I'm going to go ahead up here and dock all my tags, and on my sensor A, I'm going to create a fault, a failure, okay? So let's see what happened. See, 1, 2, 3. So the sensor is a failure. You see I created a failure here. So let's see what happened. After 30 seconds, I should be timing out and everything should be reset. Bingo. Boom. That's it. You see, everything resetted again. My logic was reset and nothing is running. This is just a precautious, just like a safety. I'm using that to make sure that everything runs well. But if a sensor is not working, well, you don't want the sequencer to be running with a fault. So that's what this run at the bottom of my program, that's what this run does. It's just a timeout bit that resets absolutely everything. And then the only way I could go back to it is just put it in run mode and then continue. Everything will work just fine like it was before, but that's just a precaution. All right, guys, I'll talk to you. I'll see you on the next scene, what I'm going to do next week. And I'm thinking of, hold on a second, let me stop this. The next one is going to be, let me check the other scene. I have done this one, this one, this one, and that one. So the next one is going to be filling tank. I'm going to do both. I'm going to do filling tank with a timer, and the other one with a level control, which is more complicated. You use a PID, and this is the one I'm going to do. Well, mostly I'm going to do this one. So I'm down one, down one, down one. Yeah, I'm going to go ahead and keep this sequence. So I'm going to go ahead and move and do this one. This one is pretty easy, but I'm going to try to keep this sequence, and I'll post the next video as soon as it's ready. All right, guys. Thank you very much. Bye-bye.